Coupling captures how strongly connected different program classes are to one another. Coupling is really problematic in practice because it has a strong influence on how maintainable and evolvable our systems are. Because if you have a class that's tightly coupled to another class, making a change to that class can often induce errors in those other classes. Also, if we go to fix a bug or add a new feature to our system, it often means that we need to fix our code in many different places, which can also induce bugs in those many different places. This also adds a challenge in terms of reuse, because if we wanted to reuse a class that we previously made within our new system, we might find that it has to come along with 5 or 10 or hundreds of other classes if they're tightly bound together. So this can be really a problem from a reuse point of view. Finally, when we're trying to understand a system, it's much easier to understand small, independent classes than classes that are all coupled to one another. So if you're looking at one class and you realize you also need to look at this class, this class, and this class, suddenly you have a whole series of code editors open that make it really hard to reason about your system. When we're thinking about coupling within our systems, what we want to really do is we want to minimize the interfaces that exist between different program elements. We also want to minimize the complexity of those interfaces so that they only reveal the minimum surface that's required to provide the functionality that's needed. Finally, we also want to minimize as much as possible the control flow constraints that exist between modules.